Good day, dear colleagues. Today I want to present you our work on the topic neuroevolutionary mechanisms in the synthesis of spiking neural networks. So let's start and look at more closely. Let's start from the general idea of spiking neural networks. Spiking neural networks are a special artificial neural network that more closely mimic natural neural network from the animal brain. In addition to neurons and the synapses, CNN incorporates the concept of the time into their operation model. The idea is that neurons in the CNN don't transmit information at each propagation cycle, like in other artificial neural networks, but rather transmit information only when a membrane potential reach a specific value, for example, which called the threshold. And as all we know, in nowadays, there are a number of methods and approach which can be used to train an artificial neural network in general. But when we talk about spiking neural network, all of them look like more synthetic. The architecture of spiking neural network consists of pulsed neurons and interconnected synapses. Pulse bundle in the neural network of impulse neurons propagate through synapses connection. A synapse can be as excisional when the member potential of neuron increase after received a signal, or slowing down. The amount of rib weight can change as a result of training. And in the case of deep spiking neural network, it is more difficult because definition of pulse bundle doesn't allow the use the popular method like backpropagation, for example. For spiking neural network, there are different methods of training. You can see the main idea of each method on the slide, but all of them have some disadvantages. Firstly, it is large computational needs. For example, each channel needs a separate quick convergence scheme. Secondly, it becomes quite difficult to get a large number of channels due to pulse destroying that occur when connection matching circuits to cochain cable. But the key problem of all of these methods, that they work with thoroughly restricted structure of the model. There are many approaches that apply backpropagation to spiking neural network with some changes. But such method can't use traditional approach and change gradient updates to spiking neural network themselves to overcome this complexity. That is why it is an urgent task to develop evolutionary method for the full synthesis of CNN model from the start with structure and to end with correction of the weights. Before talking about our proposed case of neuroevolutionary mechanisms, let's talk more closely about composite pattern production networks technology, CPPN. In this technology, demonstrate good result in combined with neuroevolution genetic algorithm because this approach allows using different types of topology of neural networks in the population and fine-tuning structure details in combined with different activation functions, for example. You can see on the slide first picture. This is not my picture. This is picture from the work of Marcus Sol, and you can find this work but this scheme very good to demonstrate this technology and this approach. In our work, we took this idea, but planning use it more strong frames because we must talk about very special structure. So the idea of CPPN transformed to idea of neural pattern, which will be changing during the synthesis. And secondly, let's talk about the methods. In general, at the beginning of evolution, we obtain a population with neural patterns about which we talked previously. That determines the connection pattern of resultant CNN. Each neural pattern is defined by encoding genetic information with the defining of its internal weight and activation function and so on. However, it is important to note that each individual neuron in a neural pattern can have any activation function from the specific set. To decrypt CNN from neural pattern, the containers from a pair of neurons are passed to the network that creates neuron pattern. The network output determines the weight and delay of the connection between two neurons in the defined neural network. This process is repeated for each pair of neurons to build a complete network. However, several nuances of this synthesis should be noted. Firstly, the position of CNN neurons in the pattern are pre-recorded. During the evolution search for each individual, that is, any mutation of modification is possible only in the form of new individual. Secondly, each solution is decoded and evaluated to complete the given task. Therefore, the suitability of solution is determined by the performance of the generate CNN from the specific task. And the last, it is that we used some mechanism to protect innovation in new solution. It can stop if they are not available. So as you can see, the most difficult and poor state of this method is evaluate fitness function, because for this we must decoding and encoding the CNN, and these take computational needs. About it we will talk later. For testing, we used well-known dataset about pneumonia patients. You can see the general information about dataset and the reference to work with this dataset. We decided to compare CNN working with another modern artificial neural networks topologies. These are recurrent and deep artificial neural networks. And architecture of these topologies you can see on the slide. In this slide, you can see the general result for all the methods. And as you can see, synthesis of spiky neural network, difficult task, because the synthesis time are the bigger than in other topologies. For example, even deep neural network synthesis more faster than spiky neural network. This is talk about pool stage in our method, what we talk about before. This stage of coding and encoding special and difficult architecture like spiky neural network. And if we talk about the accuracy of solutions, it must be noted that for diagnostic, for example, really, spiky neural network demonstrate good accuracy. But when we talk about some tasks like forecasting, and we can have some errors in our accuracy, maybe recurrent or deep neural network, not so bad idea, because they synthesis more faster and accuracy good. But yes, have some problems, but not so critically. In conclusion, something like summary of our work, I must say that really working with spiky neural network, it is very interesting investigation for us, because this is really interesting architecture and topology. The solution are very interesting, but when we talk about such difficult structure, we must say that using Neuroevolution not bad idea, because it having disadvantages which have previous methods. But maybe the combination of Neuroevolution approach with some methods from the reinforcement learning can demonstrate even better results. What is more interesting idea using indirect encoding of neuron patterns, which we use in our work, because using maybe not the structure of CNN, but something like the rules of building the CNN can demonstrate more better result, because this is per stage about what I talk. Can be more faster working, because we talk about rules and some condition of neural network, not all the structure. And the future work, it is really using such special topologies in the future, but with something fine-tuning mechanisms, which will bring more better results. So I want to thank you for attention, and if you have some question, you can contact us. Goodbye.